This is the Chapter 3, Sections 3 and 4 quiz review for Carroll Middle School. We'll go ahead and get started here with the first topic, which says, what holds atoms together in a molecule? And as we saw in the lab, we saw it was chemical bonds. And in our example, we saw them actually being represented by springs in our model. We had those springs connecting the two colored spheres, and that was actually the chemical bond in that case. The next topic says explain how to find the volume of an irregular object. Irregular objects would be anything that you cannot easily measure the volume of, so pretty much anything besides a rectangular object. The first thing you do is you fill a graduated cylinder 2/3 full with water. Then you record the beginning volume. You place the object in the water and record the ending volume. Finally, you have to subtract the beginning volume from the ending volume, which would be volume is equal to ending volume minus the beginning volume. After you go through and solve that, you find out what your volume is. Since it's a solid, you need to remember to change it over from centimeters cubed, or from milliliters to centimeters cubed, so that you have the correct units for it. Because remember, milliliters is to measure liquids, whereas centimeters cubed is to measure solids. The next topic asks you to list examples of exothermic changes. Remember, exothermic means that the energy is exiting the object or the reaction. So the energy is leaving or exiting. That's why it's exo. Some examples of this would include burning wood. As you burn a log in the fireplace, for example, generates a lot of heat. So that's one great example to think of, as well as explosions, car engines running, and the light bulb actually is a nice example of an exothermic process because it gets warm. The next question asks what makes up all basic particles. All basic particles are known as atoms. That's what everything is made out of. You, your dog, the floor, everything is made of atoms. The next question asks what tools do we use to measure the volume of a liquid? And this is generally in the lab we will use a graduated cylinder. Now there are a lot of other techniques you can use, but this is the most common one that you'll use all through middle school. High school you might start to see some other new techniques, but they pretty much all look like graduated cylinders anyways. The next question says to list some examples of physical properties, and there are a ton of them. I'm only going to list 6 of them. The first one is melting point. This is the temperature at which a liquid or a solid changes to a liquid, like ice melting. Boiling point, which is the temperature at which something boils. Freezing point, when it freezes. Its color, texture, density, all those kinds of things are examples of physical properties. Basically, they're things that you can measure or see without changing it to something new. If it's a chemical property, then we're getting something new, or it'd be changing to a different substance. The next question asks what is the smallest particle of an element? If you haven't figured out yet, atoms are an important thing on this quiz. The smallest particle of an element is an atom. The next one, does a substance change after a physical change? The answer is quite simply no. It's still the same substance. A great example to think of is this ice cube melting right now. It's ice, so it's solid water, and it's changing into liquid water. Both situations, they are still water, and so that's how you know that it is a physical change. You have the same stuff when you started and when you ended. Even boiling water is still considered a physical change because even though you can't see the water as much anymore, it's still being evaporated or boiled off into the atmosphere, and it's still water in that situation. Now, conversely, does a substance change after a chemical change? In a chemical change, yes, you do get a new substance formed. Something different is made. And this is so different that it really can't even change back to what it was before. For example, wood burning. If you look at this example here, you can see I have a picture of a campfire going, and you can see the wood burning. You can see the exothermic, you can almost feel the heat coming off of it looking at it, but you can also see the flames going on it. And you can see the wood has started to turn to ash. It's started to get that white soot on the outside. And that is actually from a chemical change that's occurring. It's burning or changing the fiber inside of the wood and releasing the heat from it by changing how it's bonded and creating new molecules. Another example is metal tarnishing, and this is kind of a word that might be new to you. Tarnishing is kind of like rusting, okay? And you can see here this silver spoon, the top half is tarnished, whereas the bottom half is not tarnished. Tarnishing is a rusting process that can occur over time, and it's common for most metals to experience some form of tarnishing. And of course, that is a chemical change because it is not silver anymore at the top, or not pure silver. It's actually silver that's reacted with something else to form a new substance. Again, that new substance test, you get something new that is different from what you had before. You had to rearrange those molecules, bonds were broken, springs were taken apart. Those are examples of chemical changes. Next question, atoms are held together by chemical bonds is called or are called molecules. Molecules are the name that we give to bonded together multiple atoms connected to each other. The next one, a volume of milliliters is equal to a volume of, and this one we've talked about during the CSI Huntertown investigation. It says that 1 milliliter is equal to 1 centimeter cubed. 1 milliliter is equal to 1 centimeter cubed. That is a great definition. You need to know this one because it will come in handy for pretty much your entire life as you see things. So 1 milliliter is 1 centimeter cubed. Just commit it to memory. It will make it easier in the end. The next one, what is a chemical formula used for? And we used this a couple days ago as we went through and looked at identifying what atoms or elements a molecule is made up of. A chemical formula is just basically the recipe saying this is what this thing is made out of, or it's the ingredient statement for it. So like if you read the back of a box of cereal, you can read all the ingredients on there. The same thing with the chemical formula. For example, carbon dioxide, its formula is CO2, and we know from that there is 1 carbon atom and 2 oxygen atoms, because remember, if there's no number after the letter, then we can assume that there's just 1. So 1 carbon, 2 oxygen. Another one that you're very familiar with is of course H2O. And you know that being 2 hydrogens and 1 oxygen atom. Again, this is the chemical formula that tells us what is actually inside there based on which elements they are. The next one, how do I find the volume of an irregular object? It shows up twice on the study guide. Pretty good chance it's going to be on the quiz. Of course, you fill the graduated cylinder 2/3 with water, then record the beginning volume. Then you place the object into the water, record the ending volume, subtract the beginning from the ending volume, of course using the same formula. Notice I said 2/3, but really it doesn't matter that much on the volume of the water. As long as it's enough to cover it, you're fine, because remember, you're going to record the beginning volume, so you already have your starting point. It will give you the right answer every single time as long as you know where that starting point is at. The next question just told you to write down the formula for density. You need to also have this committed to memory as well. Density is of course equal to mass divided by volume, or m/v. Next you'll learn that it's also density is equal to m/v. It looks like a broken heart because density breaks your heart. So make sure you remember this. Density equals mass over volume. The next question says, what makes up all elements? And sticking with the trend of this podcast, of course, that is atoms. Atoms are what all elements are made up of. The final topic on the study guide says, what is each part of this molecule called? You can see on this is a picture of a water molecule, and you can see the chemical bond where my arrow is pointing to. That's just one of them. There's also one between the lower hydrogen atom and the oxygen atom. And so you can see the hydrogen atoms are bonded one time to one other item, whereas the oxygen atom is bonded to 2 different hydrogen atoms using 2 chemical bonds. Notice that the atoms then are the 3 spheres. There are 2 hydrogen atoms and 1 oxygen atom. The oxygen atom is represented in this case by the red circle, while the hydrogen atoms are represented by the 2 blue circles. As I promised during the when I hand out the study guide, there are some good questions to look at as well. Looking through your textbook, page 115, questions numbers 1 and 4 are always beneficial to look at. Page 116, I like questions 12, 14, 15, 17, and 18. I'll tell you 18 is a little bit of a longer problem, but it does have some good concepts in it that will show up on the quiz as far as some things you'll need to be thinking about. And questions 3 and 4 on page 117. To wrap up this podcast, just want to remind you of some tips for success. Of course, we always suggest that you study early and often. Hopefully, you've already filled out your study guide before watching this podcast, but if you haven't yet, fill it out and check it with your teacher. We'd love to see you come down and visit us during charger time. We are happy to check study guides at that point and help you out with that. Look at what investigations you did during that section. This quiz will have questions that are related to this investigations that you just did. Those two investigations will more than likely be your claims and evidence type questions you're going to see on the quiz. Review the words in your glossary. All of them are fair game for this section, as well as try the practice questions. Finally, ask questions on My Big Campus and in class, and of course, as always, study with a parent or friend. Get mom and dad involved. They are happy to help you out, and it will help you to make sure you're successful. If you have any questions, jump on My Big Campus and ask them on there, or join us in class and ask then.